The real nightmare of buying a CD player in 2026 isn't that the technology is outdated. It's that the manufacturers are burying you in so much digital jargon that you are paralyzed from making a choice. As an engineer who has spent decades designing custom cables and matching digital interfaces, I can tell you that the modern obsession over DAC chips, I2S connections, and proprietary clocking is completely distracting you from what actually matters in your audio system. If you don't learn how to cut through the marketing noise and understand the fundamental mechanics of digital audio, you're going to end up overspending on the complicated mismatched system that permanently locks you away the true sound quality of your CD collection. Welcome back to a new series we're doing here at Moon Audio. Grab your coffee and settle in for what I'm tentatively calling my morning muses. Today we need to have a serious talk about why everyone is suddenly so confused by spinning plastic discs. Over the last year, we have seen a massive resurgence in compact discs and super audio CDs. The demand is real, but here is a huge problem. People are coming into this market looking completely shell-shocked. It is not like it was just 20 years ago where you just bought a box with a brand name you liked and called it a day. Today, if you want to elevate your CD playback, you end up with a headache, feeling like you need an electrical engineering degree just to understand what the talking heads on YouTube are telling you about. They are throwing around terms like jitter, ladders, R2R architecture, PCM, DSD, Saber chips. It sends people into an absolute tailspin. I recently had a conversation with a customer who reached out. He was ready to pull his hair out. He had just spent thousands of dollars on a high-end CD transport and a separate digital converter from a completely different manufacturer. He was trying to connect them using I2S connection. Now, on paper, I2S is essentially the gold standard for low jitter digital audio transfer. It is a board-to-board interface that separates the audio data from the clock signal, which is fantastic for audio fidelity. But here is what the forums didn't tell him. Originally, Sony, who owned the high-resolution SACD format, severely restricted how digital audio could be exported from a player. They were terrified of copyright infringement and people ripping pure, high-resolution files, so they locked the format down. Fast forward to today, and manufacturers started using I2S over standard HDMI cables to bypass those old restrictions and get the pure signal out. The nightmare? They never agreed on a universal standard. Every single brand essentially uses a completely different pinout configuration depending on the HDMI configuration and your devices. To get these two premium devices to talk to each other, you have to actually dive deep into the internal menus of the transport and manually reconfigure the pins just to align the data streams. It is incredibly frustrating between brand to brand. Now, when I tell stories like this, the number one objection I hear from people is, but Drew, isn't streaming just easier than dealing with this old hardware? Yes, streaming is absolutely, undeniably easier. And to be incredibly clear, streaming does not ruin audio quality. The high-resolution files on platforms like Qobuz and Tidal sound fantastic. But convenience always costs you control. That is the crux of this entire movement back to physical media. So how do we navigate this hardware nightmare so that you can actually enjoy your discs? We need to demystify the technology and simplify the advice into exact actionable steps. First, we have to stop fearing the DAC. A lot of people getting back into this hobby get completely paralyzed wondering if they need an AKM chip or an ESS Saber chip or an FPGA, blah, 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 because someone online said one destroys the other. I need you to understand that any device that takes a digital signal, ones and zeros, and turns them into an analog signal that you can actually hear is a DAC. Your smartphone has a DAC. Your computer has a DAC. Your television has a DAC. In high-end audio, the specific brand name stamped on that tiny piece of silicon matters significantly less than the overall engineering of the entire circuit. What really dictates how a CD player sounds is the power supply and the quality of the analog output stage. The analog stage takes the tiny electrical signal from the DAC chip and amplifies it so it can travel to your speakers and your other equipment, obviously, first before it gets to that speaker. If a manufacturer uses a brilliant DAC chip but pairs it with a cheap, poorly designed analog output stage, it is going to sound harsh and fatiguing or something else. If you are a listener who just wants to get your CDs out of the basement and press play without a headache, you do not need to stress over the internal DAC. Buy a solid, well-engineering single-box CD player from a reputable brand. A CD player that has everything living in one chassis. You put the disc in, you press play, and music comes out. It's a plug and play in the best possible way. And the best part is that almost all modern CD players feature digital outputs on the back. This means if you ever decide you want to experiment with a standalone DAC 5 years down the road, you can simply plug a digital cable into the back, bypass the player's internal DAC entirely, and essentially use that CD player as just a transport. Which brings me to our next actionable step. If you are an audiophile chasing absolute reference level sound, you eventually need to stop using an all-in-one box. You must physically separate the mechanical laser reading the discs from the electrical circuits converting the audio. You have to think about this logically from an engineering standpoint. Reading a spinning disc is a highly mechanical process. It is incredibly prone to physical vibration, disc wobble, and tracking errors. When a CD player vibrates, the laser struggles to read the data correctly. When it struggles, it relies on error correction algorithms to essentially guess what data is missing. You do not want your audio gear guessing. Converting digital audio, on the other hand, is incredibly sensitive electrical process that is prone to crosstalk, power supply noise, and other interferences. When you cram a vibrating mechanical motor and a sensitive electrical converter into the exact same chassis, they are inherently sharing the same space, often the same power supply, which introduces noise into your signal chain. This is exactly why a dedicated CD transport exists. A transport has absolutely no built-in DAC. It cannot play music on its own. It has one single job: read the disc as accurate as possible and send a pure digital signal to your external DAC. When a device only has one job, it can do it exceptionally well. The entire design becomes strictly focused on vibration control, precision clocking, and error-free data retrieval. By isolating the mechanical reading process, you virtually eliminate the need for error correction. You get a pure digital data stream. Furthermore, using dedicated separates is the exact solution to that I2S pinout nightmare I mentioned earlier. If you buy a dedicated transport and a standalone DAC from the exact same manufacturer, such as linking a Bricasti transport to a Bricasti DAC, they use proprietary connections designed specifically to communicate with each other. It completely eliminates the guesswork and delivers low-noise data retrieval without you having to be an engineer. Finally, our last step: unlock your discs. The biggest problem with streaming services today is the algorithm. You have zero control over what the record label decides to serve you on any given Tuesday. They take a beautiful, dynamic, original studio master from the 1980s and quietly swap it out overnight for a heavily compressed, incredibly loud, modern remaster. This is what's known as the loudness wars, and it absolutely flattens the life out of the music. Getting back into physical media isn't about pure nostalgia, it's about taking back your mastering. When you buy a specific CD, you know exactly what it is. It is always going to be the exact same master locked onto the disc forever. If you've been collecting physical media for years, there is a very good chance you own SACDs without even realizing it. SACD stands for Super Audio CD, and it is a high-resolution format that offers significant better detail, depth, and dynamics than standard CDs. A lot of SACDs are hybrid discs. This means they have two distinct physical layers: a standard CD layer that will play on literally any CD player in the world, and a high-resolution layer that will only play on your hardware specifically that supports SACD decoding. You might have been playing these discs for decades without ever hearing the textures they are actually capable of delivering. Check the back of your jewel case. If it says SACD or hybrid SACD, you have a high-resolution disc. To unlock that extra layer of clarity, you just need to ensure the single box player or transport you chose specifically supports the SACD format. When you hear an SACD decoded properly for the first time, you will notice it pulls out the nuances in songs you have heard thousands of times before, but breathes entirely new life into that collection. At the end of the day, engineers are constantly pushing the boundaries of how good digital audio can sound. But my best advice to you is not to feel overwhelmed. You do not need to absorb all the jargon to build an incredible system. You just need to understand the basic mechanics and match the right tool to the system you're trying to build. If this video helped clear up some of the digital confusion for you, make sure to hit that subscribe button down below for more no-nonsense audio engineering advice. And if you're ready to upgrade your system, you must know exactly which type of gear fits your setup. Kayla made a complete breakdown answering whether you need a standalone player, a dedicated transport, or an all-in-one unit. Click the video on your screen right now to find out your perfect match, and we'll see you over there.